Okay, this video we're going to take a look at balancing chemical equations. Now, so far we've looked at the conservation of mass lab and the concept behind the conservation of mass, and then we got introduced to balancing through the cutout activity. We're going to put that concretely into some notes now. So why do we balance chemical equations? It's all because of this guy, Antoine Lavoisier. He was the first one that said matter cannot be created nor destroyed, leading to the conservation of mass law, stating that whatever mass we start with on the reactant side has to be what we end with on the product side, and therefore whatever count of each element we have on the reactant has to be the same as the count on the product. So in order to do this, we need to be able to count atoms. Quick review: subscripts only apply to the element thereafter. And when we have parentheses, we distribute the subscript outside into the inside by multiplying with the subscripts on the inside. A little bit of practice. You're going to go through and count the atoms in each of these. I'm not going to go through them. You can check your work on the key in your teacher's room. A couple things to remember: these subscripts only count for the one they're attached to, like this. When we have parentheses, like this one, we are going to multiply this 2 into both of the subscripts on the things inside. So the N has an invisible 1 subscript that'll be multiplied by 2. The O has this 3 that'll be multiplied by 2 when we're counting. So pause the video, try that out, then check your work. Now, in a chemical reaction, water is made from which elements? So we have hydrogen and oxygen. Okay, so that's H2 plus O2. Now we have our pictures there. These make water, H2O. There's our picture. Now, hydrogen and oxygen, this side is what we call our reactants. This side, our water, is our products. Okay, now we need the same number of circles of each color on the left side as we have on the right side. So 2 blue circles, 2 blue circles, 2 orange circles, and I only have 1 orange circle. So what do? I need 2 of these. So notice I put this number in front. That is what we call a coefficient. Coefficients are large numbers, okay? They're different than subscripts, and they apply to everything in that compound. So they apply to everything that they follow, unlike subscripts that only apply to the thing they are attached to. So I now have 2 H2Os. Notice I added a whole second molecule here. That balanced out my 2 orange circles, but now I have 4 blue circles, which means I need to add 2 H2s. Okay, I added another H2, giving me 2 total. Put the coefficient up there, and then I have 1, 2, 3, 4, which balances it out. Now, when you're doing these, we do not need to put the 1 coefficient here, just like we don't write the 1 subscript. The only time you will need to do that is on a Schoology quiz. Okay, both sides are balanced, so we are good. When balancing chemical equations, you may only add coefficients. You cannot add subscripts. We do that first when we're crisscrossing charges, and then we go and we balance with the coefficients. So some tips for balancing chemical equations. We usually balance carbon first and hydrogen last. Any elements that are all by themselves, meaning they're not bonded to anything, you want to balance them last because those are easy to change. You're going to balance the elements that are in multiple reactants or products last. Okay, so here's some examples. We have CH4 plus O2 making CO2 and H2O. So I'm going to start out by counting my atoms. I've got 1 carbon, 4 hydrogen, 2 hydrogens, 2 oxygens, 3 oxygens. Okay, so my carbons are good. My hydrogens, though, I need to fix. I put a 2 there. That gives me 4 total hydrogens. Notice I changed this in my count. Now I have 4 and 4. Okay, now the problem with putting a 2 there is it not only changed my hydrogen count, it also changed my oxygen count. So it changes my O2 now to 4, which means I need to get 4 on this side. Okay, so I put a 2 over here, and that gave me 4. Now notice that I balanced oxygen last because it's the one that's all by itself. Okay, another tip is to treat polyatomics in 1 unit. Now this only applies if I see the polyatomic both on the reactant side and the product side. So here I see NO3 over here in parentheses, and I see it over here all by itself. I see OH in parentheses. I see it over here on the left side as well. So that means when I count my atoms, I can keep NO3 all together. Now, will this work if I break up NO3? Most certainly. However, it'll be a little more challenging because you got all the more things to count, and you have oxygen here and oxygen over here, so it's going to get really messy. So I recommend if they're on both sides, keep them together. So I counted my atoms. Now where do I start? Start at the top. Magnesium, 1 and 1. We're good. NO3, 2 over here, 1 over here. So I find magnesium up here. I think, okay, what do I multiply that 1 by to get it up to 2? Answer is 2. So I put the 2 here. Okay, 1 times 2 is 2. Make sure that 2 coefficient gets up there. Now, that doesn't only change the NO3. It also changes the Na. So now my Na needs to also be multiplied to get me 2. Uh-oh, that screwed things up. I now have 2 NAs on my products and only 1 Na on my reactants. So again, I'm going to put a 2 there. That applies to my Na and to my OH. So it gets me 2 and 2. That worked out perfectly because the OH on my product already had 2. So now we're all balanced. Okay, last tip. If you end up with an odd number and you can't balance it, you're going to double all the coefficients, recount, and then finish your balancing. So let's look at one like this. Okay, I already counted these for you. So I got 1 K, 2 Ks. Now this MnO4 is a polyatomic, but see how I don't have MnO4 on this side, so I can't keep those together. Okay, so I got 1 K and 2 Ks. I'm going to put a 2 coefficient here to get those balanced, but that changes all of my counts on my left side. So I had to multiply the Mn by the 2 and the O by the 2. Okay, now my Mn is not balanced. So I put a 2 there. That gives me 5 total oxygens. Now, do you guys see how I get 5? I've got 2 coming from my O2, 2 coming from these 2 MNOs, and then 1 coming from the K2O. So now, how do I get it balanced? There's no way for me to add a number here without messing up something else. Okay, because if I added a number in front of here, it would mess up the K's, which are already balanced. If I added a number here, well, it's not going to do anything because if I add 2 more, I'm going to get to 7, and then 2 more, I get to 9, and now I need more on the left side. Okay, so I think back to my tip. Double all the coefficients. Okay? So we can't have half of this exponent because the only way to do that is to have a half an exponent, right? 2.5. So I'm going to double all the coefficients. See, I doubled this to a 4. I doubled that to a 2. I doubled that to a 4. And then that allows me to get 5 here. Okay, so if I recount now here, I've got 4 Ks, 4 MNs, and 16 Os. 4 Ks, 4 MNs, and 2 plus 4 is 6, plus 10 is 16. So now I've got them all balanced. Okay, this one, Sb2O3 plus NaOH makes NaSbO2 plus H2O. Okay, whoops. You're going to go ahead and balance that yourself.